Hello everyone, my name is Avinav Valada. I'm an assistant professor and head of the Robot Learning Lab here at University of Freiburg. And today I'm going to talk to you about our work on coherent scene understanding of dynamic environments. So most of you might have heard about this task called semantic segmentation, which is one of the most fundamental tasks for scene understanding. And this is used in a variety of domains such as self-driving cars, in robotics, and so on. So here our goal is to identify the semantic elements of the scene in the scene, and we want to do this pixel-wise. So here, red pixels denote people, blue pixels denote cars, and this is what we want to get from our neural network, for example. And here, as you can see, there's no instances reasoning about instances in the scene. So here every instance is identified as the same. So then we have a complementary task, which is called instance segmentation. And here we only focus on identifying individual instances of objects, such as, is this person different from this person, and this instance of a car is different from another instance of a car, and so on. But the problem here is that we don't have any reasoning about the background classes, such as roads, sky, buildings, and so on. So more recently, there was this new task that's proposed that's called Panoptic Segmentation, which basically combines these two tasks of semantic segmentation and instance segmentation to do it end-to-end in one convolutional neural network. And this is the goal of our work here. So here, as you can see, you can see both instances of objects that are colored, and you can also see background classes. So if we can also represent this in terms of borders, like in the video below. Here you can see that individual instances of objects are denoted by a white border around each object, which then tells you that this instance is different from another, and so on. So here is another image. Here we show that, so let's define what panoptic segmentation is. So here we can define it as a dense class prediction problem where we want to delineate object boundaries from each other. So here, the white border once again tells you that a specific instance of an object is different from the other. So recently, we proposed our efficient PS architecture for panoptic segmentation. So here's, let's briefly go over this, but here you can see the architecture of our proposed model. So we here propose a new backbone, which is composed of an encoder and what we call as a two-way feature pyramid network, or FPN. We then have the semantic head, which is in yellow blocks, as you can see here. The